So we're about to read paragraph 4, which is about water's ability to dissolve other substances and other matter. And this is a very interesting property of water, and it allows water to wear down rocks, mountains, concrete, really, really hard substances. But it also allows water to mix up with and dissolve other substances like salt or Kool-Aid. So let's take a look at paragraph 4. What are the properties of water? And we have looked at a number of properties of water now. We've looked at polarity. We've looked at surface tension. We've looked at cohesion, which in fact causes surface tension. We've looked at adhesion. We have talked about capillary action. And now solvency. Another property of water is its solvency. A large number of substances that are attracted to water will mix or dissolve in water. For this reason, water is often called the universal solvent. Notice how all three of these words have the same root. Water is able to dissolve many substances because of its polar molecules. The positive and negative ends of a water molecule attract the molecules of other polar substances. This attracting or pulling force causes other polar substances to pull apart into individual or separate molecules. An example of this occurs when you place sugar in a glass of water. The water molecules will surround the sugar molecules and cause them to break apart or to pull apart from the other sugar molecules. Before long, the entire glass of water is sweetened. And another example of this was when we made soap. We found that the fat that we use to make soap is attracted to water. And so when water comes into contact with soap, it attracts or attaches to the soap molecules and pulls them away. And of course, we know that soap molecules are made up of fatty acids, and we remember that experience where we made soap. So this whole idea of polarity causing solvency, or giving water the ability to dissolve other substances, is pretty cool. Let's take a look at a couple of sketches, and I'll explain a couple of sketches to you. So not only does polarity cause cohesion, not only does polarity cause surface tension, not only does polarity cause adhesion, not only does polarity cause capillary action, but polarity also causes water to be able to dissolve other substances. And so polarity and solvency kind of go hand in hand. So this sketch is a pretty simple and direct and straightforward sketch, and I think you'll get the idea of what happens. But when we have water and we put something like salt in it, you'll get one little salt crystal that will have water molecules all around it, and because all of these water molecules are like little magnets, and because salt has polar qualities, the water molecules will begin little bit at a time to tug at or attract the sodium chloride molecules off of the crystal and out into solution. And so we wind up starting to have sodium chloride molecules mixing out with the water molecules as the salt crystal wears away or wears down, because the water is pulling the sodium chloride molecules off of the crystal structure and out into solution. Now, the interesting thing about this is that sodium chloride, or salt, doesn't actually become bonded to water, it just kind of goes out and mixes with it and becomes a solution, goes out into solution. So little by little, and what you're seeing here, and I think you're probably getting the idea, is that if we're stirring up the water, like over here, and we have salt in the water, and little by little, the salt, the sodium chloride molecules are becoming mixed, and they come off of the crystal structure. Before long, what will happen to this salt crystal? In time, if we keep stirring and we keep everything moving, in time, this whole salt crystal will go away and it won't be there. And all of the sodium chloride will just be mixed in with the water. This is how water dissolves other substances. The little water molecules pull at the molecules of the substance and pull the substances, literally pull the substances apart with their polarity, because they're like little magnets. How cool is that? Let's make sure that we have paragraph marked. Descriptions: solvency, dissolve, solvent. We mentioned earlier that these are all linked together. And solvency, dissolve, solvent, these all have a root word, solve, or to dissolve. But the root here is to pull apart, to mix up. Let's just write that in. Solvency, to dissolve, to pull apart. And with your blue marker, just a couple of main ideas. Water is often called the universal solvent because water is able to dissolve so many different substances. We understand polarity already, and again, you guys have seen this plenty of times, but it never hurts to sketch it again. Let's make sure that we link that to the context, polarity of water. So the positive and negative ends of a water molecule attract the molecules of other polar substances. This is so important, and it's so cool when you realize what's actually happening. And then finally, an example of this occurs with sugar in a glass of water. Our example, when you mix salt in water, you get salt water or ocean type water. And we looked at how that actually works when a salt crystal is broken down and dissolved by water. And here it is again. Please make sure that you get these sketches in this paragraph, that you get all of the markings done, all the margin notes, and then we'll take a look at paragraph 5.